Welcome to my work solutions for the Edexcel Higher paper from the November 2019 series. As you can see, it's paper 1, so put your calcs away and let's get on with it. Number 1, when you're finding the lowest common multiple, feel free to write them out. Do your 108 times table. About the 7th or 8th one should get it, but always worth doing it properly, just in case the numbers are a heck of a lot worse in your real exam. So 108, I'm going to split it to 9 times 12, which is 3 threes. And don't be afraid of a three-way split. 3 times 2 times 2. And we've got it decomposed into prime factors. The 120, same goes. And obviously, if you want to do yours neater than mine, feel free. Also a three-way split. 3 times 2 times 2 is 12. Those of you neat freaks out there probably having a heart attack at that presentation. Loads of people seem to prefer the Venn diagram approach, so let's go for that. There's a 3 in common into the centre. There's a couple of 2s in common, also down the middle. And the leftovers, the 3 and the 3, they're just for the 108. The 5 and the 2 left over, just for the 120. If you wanted to find the highest common factor, that's multiply the intersection, 3 times 2 times 2. But if you want the LCM, it's a case of multiplying all of them. And, there's various ways of doing this. I've gone for the 3 times 3 times 3, gives you 27. 5 times 2 times 2 times 2 gives you 40. And that's all the working out I need to do. 108 giving me 1080 for the LCM. And yeah, you would have got there quite quickly doing your times tables, writing out the multiples of, but again, better off with a method that works for much worse numbers. Number 2, one of them wordier kinds that people aren't a big fan of. Don't read the question as a whole. One sentence at a time. Top line tells us 60. Half are women. Get that worked out. 30 it is. The number of women is 3 times the number of men. Well, thankfully, we know how many women, so we know how many men. The rest are children. And you build it up one at a time. The ratio of the number of children, well, that's 20, to the number of men, that's 10, can be written in n to 1. We want a 1 on the right-hand side, which is done by dividing by 10. Hey presto, we're there. Number 3, typical 4 operations, non-calc. If you've got a mixed number, make them improper. Big times bottom is 4. Add the top, gives us 7 over 4. And 1 times 3 is 3. Add the top. You could go straight for top times top, bottom times bottom, and cancel it down, etc. I'm going to go for, there's a 4 on the top, divide by 4. There's a 4 on the bottom, divide by 4. Now I'll multiply the numerators and the denominators. It wants the answer as a mix. So how many 3s into 7? 2, with a remainder of 1. And the denominators stay the same. Number 4, I've had to cheat because I can't do that with an electronic pen. There's a few ways of going about the first stage. What I did is I opened my compasses and I opened them to the distance from P to D. I then put my metal point and drew this arc there, that arc. That went through D and another place. You then pick up your compasses and you open, don't open them, they're already open. From each end, metal point on there. I drew that semicircle-ish. And metal point on there. I drew that semicircle. And as you can see, joining them up gives you your perpendicular bisector, but also allowing, thickness of a pencil, the odd little bit out here or there. They always allow plus or minus a small amount on the overlays that your examiners will mark from. So not a big deal if it's very, very slightly out, 0.1 or so. Number 5 on the surface of it looks very tricky, but just stick to the basics. One of the basics being angles in a triangle make 180, 180 take away 75, 105 take away 51, gives us that large angle being 54. 2/3 of it, 1/3 of it. 1/3 of it is 18, 2/3 of it is 36. They're the angles here. The little one being 18, large one being 36. Work out the size of angle B to D to C. We've got another 180 minus. 180, take away your 51, take away your 36. Feel free to mental arithmetic or column it. As long as you get 93, you've banked the marks. Number 4, I'm reading that 4 red bricks. Number 6, again with these wordy ones, one line at a time. If 4 red bricks have a mean of 5, their total is 20. 4 times 5. 5 bricks have a mean of 9. Their total, 9 fives. And another brick weighing 6, which means you're getting your total weight 71 kilograms for these 10 bricks. The mean of these 10, though, is 71 divided by 10, 7.1, slightly bigger than 7. So is Donna correct? Donna says the mean of the 10 is less. So is Donna correct? We need a big no. She's not correct. Next, some laws of indices. When you've got power to a power, this is the situation where the powers are multiplied. P to the power of 10. Here we're dividing, so for the letters, you are subtracting the powers. Let's do numbers first though. 12 divided by 6 is 2. The power of x is 7 minus 3. And the power of y is 3 minus the one you can't see. And on we go. Again with number 8, scale drawing can't really do it on an electronic pen. So there's the cut and paste from my work solutions, because I've already done these on my worked answers. Lena sails on a bearing of 70 degrees. You get your protractor and you measure 70 to get the bearing. She sails for 1.5 hours. If you're doing 12 kilometers per hour, you'll do 12 in the first hour and 6 in the half hour. In other words, 18 kilometers in total. 1 centimeter is 4 kilometers. We need to divide by 4. Halve it and halve it again. Whoops. So 4.5 centimeters. You need to measure 4.5 centimeters, so ruler or pair of compasses will suffice. But you've already got the bearing. There we go. 4.5 in that direction. Find I, the distance in kilometers of port Q from. So you get your ruler, you measure that distance. Now I will just say the original exams do have a tendency to be slightly larger than any print-offs you may have in school or you might have printed off yourself, particularly if your teachers reduced it down to A5 size. So my answer of 5 might be slightly under what the real answer is. That could also affect the bearings slightly. But as you can see, I got 5 centimeters. It's a multiplier of 4. So on my diagram, I get 20. The mark scheme allows 20 to 23. So as I say, mine's probably slightly an under answer. It's still within acceptable limits though. When you measure the bearing from lighthouse L means you're stood at lighthouse L and it's a clockwise angle. Too big for your protractor, might be okay for angle measurers. So I measured the small angle, I got 35. These will make 360. 360 minus my 35 means I got 325 for part double I. Mark scheme allows 317 up to 330. So probably I've got a better answer there than I probably did for my measurement, but still both correct. On we go. Number 9, 18 minutes. Lots of ways of going about this one. I'm about to do it a very slow way, but it does illustrate what's going on. It's nice if your brain, doesn't like 18 minutes because it's not a standard fraction of an hour, really, is it? We've got 72 kilometers per hour means 72 kilometers is covered in 60 minutes. We can go to 6 minutes by dividing by 10. And we can go to 18 minutes by trebling or multiplying by 3. And that gives us our answer of 21.6. And then you can use a similar approach for part B. David says, I'm going to start with the 20 meters per second. 20 meters, you could have used some information from above, by the way, to carry on, but I'm going to go the other way around. 20 meters covered in 1 second. If I want to go to 1 minute, that's a multiplier of 60. So you're going to have 60 times the time. You'll get 60 times the distance. Let's go to hours. That's also 60 times the time. So it's going to be 60 times the distance. We times by 6. And we stick a naught on. Not forgetting that's in meters. Divide it by 1,000. That looks like a 4, doesn't it? It's meant to be 72 with a comma. So it's 72 kilometers in an hour. David says 72 is faster. Is David correct? No, because they're actually the same. Whoops. They're actually the same. Again, yes, I've used a longer way of doing that, but it's nice and secure. It shows you what's going on. And it's one of those that will always work, even when the numbers aren't as friendly. Number 10, another one where I've had to cheat, because otherwise it takes me ages to do it with my electronic pen and stuff, and it'll be rubbish as well. You must plot using your upper class boundaries, so 40 along, 5 up, and so on, and you should join them with a ruler, although because it's a cumulative frequency graph or table, you can do a curve, but why would you bother? Just risky. Use a ruler. It asks on the next page for the interquartile range. I'll stay here. Quarter of 40 is 10. So go along to your graph and down. 3/4 therefore is 30. Go along to your graph and down. Your interquartile range will be those two numbers subtracted. I got 1745 to give me 25 minutes. Mark scheme allows anything between and inclusive 21 to 28. Next bit, 40 of the 40 chosen at random, find the probability. Well, get that stuck in straight away because it's out of 40. We now need to go back to our graph, find out how many people are in between 50 and 90, hence my other lines, but going in the opposite direction. There's my 50, up and across, I get 15. There's my 90, up and across, I get 37. 37 minus 15 means 22 people are between. No, you don't have to cancel it down, and yet the mark scheme allows that 22 to be any number between 19 and 24 inclusive. Number 11. Lots of complicated ways of doing this. Don't. Actually a lot simpler than you might think. Shafiq takes at random 30 counters, basically 1 out of 6 of the counters he takes out ends up being yellow. Well, that means we knew that 12 of them were yellow. We need to divide it by a 6. In other words, times it by 6, because we got 1/6 of the counters, and 1/6 of 72 means the 12. They're in the same proportion. In other words, that's the other way of thinking about it. That's really what's going on. Number 12. What's Spencer done wrong? When Spencer doubled both sides to get rid of the divide by 2, he didn't double the 5. So any sentence that means Spencer's 5 should have been doubled to give you 10 would have been a correct answer. Writing as a single fraction, I go with the technique of multiplying the denominators. And then the idea is, I know some teachers will call it cross multiplication, 5 times 3x and 2 times x plus 1. Some teachers will keep the brackets in and so on and so forth. I've done a couple of questions the long way. I'm doing this one the short way. The bottom stays the same, so I'm worth a couple of marks. Just simplify the top. There's 17x, and there's 2. On to B, which is a bit of a weird one. To illustrate it, I'm going to just remind ourselves what squaring a bracket means. Squaring a bracket means multiplying it by itself. So I'm just writing it out the long way. I did A the long way. I did A the short way. I'm doing this the long way. What have they got in common? Take them out. They've got an X and a Y in common. What's left over? An X and a Y and a 3. And if you wanted to keep them inside brackets, that's perfectly acceptable. But I wouldn't bother. It's only worth 1 mark, and that's the answer. That's how it's displayed in the mark scheme. Number 14, good old algebra, in the context this time of area of a triangle. Now, if you don't like these questions, my advice is always the same. If you knew these measurements, what would you do? Well, you would find the area of the triangle by doing a half base times height, or you would work backwards to find maybe the height or the base. Well, that's exactly what you do. It's just with algebra. The area is a half times the base times the height, and that gives us 27.5. I'm going to double both sides whilst expanding the brackets. Do your preferred method for expanding brackets, whether it's loops, grid, or whatever. I'm just doing this one the quick way. The x loop will be x squared, the numbers loop will be -8, and we'll get 4x there minus 2x. 2x in the middle. If you're going to solve it, it being a quadratic, you want it equal to 0. Take away 55 from both sides. Now time to factorise. Two numbers that multiply together to make -63, but add together to make +2. Rack your brains, make a list. You may have seen it before and it jumps straight into your head, but either way, whichever way you do it, there we go. Which means one of your answers is potentially -9. If it was a pure algebra question, that would be fine, but not here. If x was -9, that means one or both of the lengths are negative. There's no such thing as a negative length. Length is not quite the same as something like depth, which could be a negative. That gets rejected. We don't want that one. So the value of x, the only value of x which we're interested in is 7. That's not the answer. It wants the shortest side, and the 7 plus 4, that'll be 11. We're not interested. We want the 7 minus 2 for the shortest side of 5. Number 15, one of them recurring decimals that you should have practiced, loads of times. Let x be the decimal. You want to budget up such that the recurring part becomes immediately straight after the decimal point, because you then have the job. You want to budge them up so that the same thing happens again. So if it's 2, you want to be multiplying both sides by 100. So we get 1000x. Now I know some teachers that would say to you, just multiply it by 10, 100 and 1000 and see where you are. And there's nothing wrong with that. Absolutely fine. You just on this occasion don't need the 100x step. Bottom takeaway top, 990, 418 point a load of rubbish minus the 4. And the load of rubbish, well, all that rubbish cancels out. Oops, forgot the x. So x is going to be the 414 over 990. And there's loads of ways. If you've cancelled it down, great. Doesn't ask you to. Lots of different steps. Halve it, divide by 3. Ultimately, it ends up at 23 over 55 if you really wanted to. But not necessary. Waste of time, actually. Number 16, rationalising means multiply top and bottom by the surd. Top times top will give you 22 root 11. Bottom times bottom, the root will cancel. It wants it in its simplest form. 22 over 11 cancels to 2. Part B, same sort of thing, but needs a bit more on the rationalising side. You need to introduce multiplying top and bottom by the conjugate, which is posh, for change the negative in this case to a positive. Top times top, root 3 times 2 root 3. Root 3 times root 3 is 3. Doubled, 6. 1 times root 3. On the bottom, you do not need to do 4 loops. You only need a couple. You need the 2 root 3 times 2 root 3. 2 2s are 4, and the root cancels. And then you get the minus 1 times the plus 1. If you do the other loops, they just cancel out, they disappear, so we're not bothered about them. You end up 6. Always keep an eye. There's nothing that cancels down the root 3, we've already got it. So it's just a case of simplifying the bottom. And you're done. Number 17. The connection here is finding the scale factor. Because when you've got a linear scale factor, that's a straight line, you would square it for the area scale factor and then cube it for the volume scale factor. Or if you know the volume, you cube root it for linear. But in this case, it's the surface area. We have the A to B. We have the area scale factor. Well, to go from A to B, it's multiplying by 9 over 4. That's how you turn 4 into 9. Times it by 9, divide by 4. So that means our linear scale factor, as I've mentioned, we need to square root it. Square root the top and the bottom. But if you're filling it with water, you're really interested in the volume of them. And the volume scale factor means you need to cube your linear scale factor. If you cube the top, you get 27. Cube the bottom, you get 8. Now the final pain in this question is they haven't told you any of the volumes. They've only told you how they are related. And they are related in a volume sense. If A has a volume of 8, B has a volume of 27. And that's your connection. If you filled up A and stuck it in B, that's how much would be in there. Do it again. Do it again. Not full yet. B doesn't get full until you put another one in. And obviously, once you go above 27, you start to get spillage. And that's it. Work out the number of times Tyler fills A with water because he needs to fill B. 4 times. And there we go. Number 18. Couple of ways of you could find the inverse function by rearranging, but because it's got a cube in it could get a bit messy. So the idea is if you sub a number into the inverse function and get an output, take the output, put it into the original function and you'll get the 50. So that's what I'm going to do. The f of the normal function, not the inverse function, I'm going to stick 3 into this. 2 lots of 3 cubed, non-calc BIDMAS. 3 cubed is 27, doubled, and hey presto, we've done. Part B, compound functions, sub a function into a function. This means G has to go into H. That means stick that into there. In other words, replace the x with x plus 2 and it's squared. Find the values of x where it's equal to this. There we go. We've got the equation. It's our old got a quadratic, we need to just expand, simplify, and make it equal to 0. Solve. So let's expand the brackets, square the first, square the last, times them together and double it. There's more x squared on the right, so I'm going to go for 0 on the left. Subtract an x squared from both sides, subtract 4x, and subtract 4 from both sides. You could use quadratic formula. I mean, no one's going to complete the square, but I've already factorised it. Feel free to AC method if you want. I've already done it though. Don't want to brag or anything. But choose your favourite method. You've got your two answers. -1 and +5 over 2. And there you go. To number 19. With these questions, you've always got to spot the connection. The 9, the 27, and the 3 are all powers of 3. Get them rewritten. Replace the 9 with 3 squared. Replace the 27 with 3 cubed. Now the power of 3, it's already a 3. And there we go. The logic now being, because the bases are all the same, the powers must be the same. So we can say that the powers are equal and apply laws of indices. So on the left-hand side, I've got 2 multiplied by -1/2. Here, I've got 3 times 1/4. And I'm dividing, which means I'm subtracting x plus 1. I'm going to take away 3/4 from both sides and get rid. I'm going to times out the brackets, -x minus 1. I add 1 to both sides, and we're there, because if -x is minus that, positive x is positive that, and on we go. Number 20, normally I draw the graphs in advance, but I'm going to risk it for a biscuit on this one. Part A, what's happened to it? It's in kind of the complete of the square form. So make sure you revise how to go from x squared to a graph which is incomplete of the square form. You change the sign there, so it's going left 1. I'm going to do that in a sec. -3 on the end would mean it's got to go down 3. So I would say pick a vertex, go left 1, down 3, and that would happen with every other vertex. So this horizontal line of 2 stays horizontal. This diagonal line of 3 diagonal lines stays. This uphill of 1 along 2 up, because they all stay relative to each other. And you won't be able to see it very well, but trust me, it's there. And hopefully yours in real life will be a lot better than mine. I've fudged that a little bit, so no one will ever know the difference there. On to part B. The point A, they've labelled it. Now, the x has been replaced with a -x. This is one of them revision points. If you don't know instantly that that's a reflection in the y-axis, make yourself a little bullet point crib sheet kind of thing. If all the signs changed, if it was negative f of x, the minus there, that's where everything changes, and that's a reflection in the x-axis. That'd flip it upside down, basically. So where does A go? Well, if you reflect it, it appears on the right-hand side. The height, in other words, the y, doesn't change. The 1 stays, but the negative x goes to positive. Number 21. Stonker of a question, if I do say so myself. Work towards it is my advice. So I want a sketch. Doesn't have to be amazing. You just have to hit the key points. So there's my axis. The first thing you do know already the y-intercept. This graph, when it crosses, will be crossing the y-axis at -5. That's picking up your first mark. How do you find the coordinates of any intercepts and the turning point? I'm afraid the turning point, complete the square. I'm going to take a 2 out of the x squared and the x term. Complete the square on the inside bit. Square halve the 4 to get -2. Square it and take it away. And when I expand these brackets, I get -4 times 2 is -8. Simplify it with the -5. But that tells us where the vertex is. The vertex is where the brackets have a value of x that means they disappear. Whoops. And when they disappear, there we go. We can fill that in, kind of. The vertex is 2 along, 13 down. That does start to give us the shape. Doesn't have to be to scale it, to sketch. That vertex, missed it by a mile. That vertex, give it the coordinate 2 minus 13. It's now these that are your problem. They are known as, yes, you've guessed it, solutions. How do you find solutions to a quadratic? You solve it. You could carry on the complete of the square and solve it from there. You could use a quadratic formula. On my other worked answers on my website, I've done it the formula way. Here, I'm going to carry on with the complete of the square. Let's add 13 to both sides. Divide both sides by 2. Square rooting. It's plus and minus the root of all that. And so our coordinates, we can now just, because they don't care about the algebra, they just want it labelling. The coordinates, when we add 2 to both sides, that is going to be 2 minus the root of all that nonsense. And that's going to be 2 plus the root of all that. Yeah, lots going on in that one, but a very good revision question, in my opinion, to remind you when you're doing bits of the quadratics, like completing a square or the formula, when you're finding the vertex, which bits tell you key bits. As I say, it's completing the square that finds the vertex. It's solving that finds the solutions. And you could have done that, as I say, by the quadratic formula. But there we go. Number 22. I've written this out again in full on my worked answers, so click some links, find the PDF. On my website, I'm not doing the job twice. I will just read you through it. To prove that they are congruent, firstly, if you don't, sometimes it's difficult to spot, by the way, so it can help you just to go over them and remind yourself which are the triangles you're looking at? And if you do that, you might spot, hey, they share a side. That's the first thing. They have B, C in common. As you'll know it with proof of congruent triangles, that's a side. Next thing, tells you it's equilateral. 60, 60, 60. That's 60 if you care. That's 120, 120 if you care and all that. But what really helps us is, first of all, angle CDB, I'll mark it with a double, is equal to angle CAB, because that's our old friend. I sometimes call it the crown when I'm talking to students, because if you draw lots of them, you kind of look like a Statue of Liberty crown, but it's not what you call it in the exam. You simply say, why are these equal? Because the angles on the same arc are equal. So we've got an angle, and you can flip that in reverse. You can say that that is equal to that. But here's your problem. They're not the angle inside the angle. They're not what you're looking for is another angle like ABC. But hold on. If that's 60, angle same arc tells us that's 60 as well. And that's 60. So you've actually got a big equilateral triangle, but guess what? This is an equilateral triangle. And there you go. Thanks to angles in the same arc, you've got loads of 60s all over the place. And more importantly, you can say that angle ABC and angle DCB are also equal. Side angle. Now the mark schemes took it through. There's low. You can go side angle. You can go angle side. All the other ways are available. I've just chosen to go that way. Oh, there we're done. So yeah, not the greatest end to a paper, but that it's all. Why did they tell us it's equilateral? If you ever find yourself there's got to be loads of 60s and 120s all over the place, and so on. So a couple of big uns right at the end, but overall not the worst paper. So again, some wordy questions. Don't get put off by them. Keep persisting. Be stubborn, and just write things down as you'd do if you knew what you were trying. If they give you X, what would I do if it was numbers? Do the same with letters. Anyway, time for me to shut up. I've gone on too long now. Hopefully that's all helped, and I'll see you on the next one.